Hi, in chapter bolts, nuts, screws, design of eye bolt and boiler stay. This topic we have to discuss in this lesson. Objectives of this lesson: upon the completion of this lesson, you would be able to calculate proportional dimensions of eye bolt using empirical relations, applications of lifting eye bolt, design of screw boiler steel, an application of screw boiler steel. First of all, let us see eye bolt. And this eye bolt generally used to lift and transport heavy loads. Consists of a ring circular cross section which is forged into a screwed shank integral to it, screwed inside a threaded hole on the top of the machine. So this is the model of an eye bolt. So this is the round shape, and there is a screw which is going to fit within the machine to be lifted. So these are the types of eye bolts. Eye bolt with egg link. This is the eye. This is also one type of eye bolt with an egg link, and there is a screw in this which is going to fit within the machine to be lifted. And this is, as you have seen earlier, this is the eye bolt and this is a screw. Eye bolt with the collar. This will be the collar, and here also it is also collar. Number one, eye bolt with egg link and eye bolt with collar. And here is also eye bolt, but without a collar, eye bolt. And this is the eye bolt with the star point. Eye bolt with the star point. These are the four types of eye bolts. Number one is the eye bolt with egg link, eye bolt with the collar, and simple eye bolt, and eye bolt with the star point. So here, design of an eye bolt. See, this is the eye bolt and the proportions of each one. See all these proportions, empirical proportions of an eye bolt. So diametric threaded portion D, and length of shank 1.5 D, and diameter of collar 2D, thickness of the collar 0.32 D, diameter of the ring rod 0.8 D, inner diameter of the ring 2D, outer diameter of the ring 3.6 D, diameter of the neck 1.36 D, and the distance between the center of the ring and the bottom of the collar is 2.64 times of D. Let us see in the figure itself. Now let us see. So here are the proportions. D will be the diameter, nominal diameter of the threaded portion, and DC will be the core diameter of the threaded portion. And the length of the threaded portion is 1.5 times of D. And this is the collar, and the collar thickness is 0.32 D, and its diameter is 2D. And here is the neck. From here to here is the neck, and this neck diameter is 1.36 D. And similarly, inner diameter of the ring is 2D, and outer diameter of the ring is 3.6 D. And from center of the ring to the bottom of the collar or starting of the threaded portion, the distance will be 2.64 D. And the diameter of this ring rod, that is, this is the ring rod, 0.8 D. And this is the curvature, this is 0.5 D radius. These are all the proportions we must remember, because all these are the standard proportions. All these are the standard proportions. Thereby we must by heart it and remember. Now, how to design of an eye bolt? So because the main function of an eye bolt is to lift loads, so thereby this will be subjected to tensile force along the axis of threaded portion. It will be subjected to tensile force, tension, so that it may fail at the threaded portion only. So its design must be based on the tensile load. So P will be the load to be lifted, and D will be the nominal diameter of the bolt, and DC will be the core diameter of the bolt, and FT, or sometimes we may take this as sigma T, tensile stress induced in the bolt. So as I told you, whenever there is load is acting on the body, that should be resisted by the body. Otherwise, it may get failed. So, in order to keep them in equilibrium, both load applied as well as resistance must be same. So, thereby, since the load to be lifted must be equal to resistance offered by the bolts. So, load is anyway P, whereas the resistance is, which is also equal to load, is area into tensile stress. Area perpendicular to the axis, the bolt, and tensile stress. And here we are going to take DC. Why? Because this is the smallest diameter of the threaded portion, which may suffer more. Thereby, the failure may occur at the root diameter only. That's why wherever the stress concentrations are more and wherever there is a possibility of failure, that area must be taken into account for the calculation of sizes and design. So thereby here there is a possibility of failure at the root portion. Thereby we are going to take root diameter into account and root area into account. This is the area perpendicular to the axis at the root, and this is the tensile stress. So this is the simple formula to calculate the size of means the diameter, nominal diameter of the eye bolt. So after getting DC, that means core diameter, we have to go for standard tables, or we have to go for a formula, that means relation between core diameter and nominal diameter. So that relation already we have, that as DC is equal to core diameter is equal to 0.84 times of nominal diameter. So that after getting core diameter, we can calculate by using the relation nominal diameter and then adapt as per the metric standards, right? This is the design procedure of an eye bolt, right? So some of the applications of an eye bolt. Here you can see an eye bolt. This is an eye bolt, simple eye bolt, right? To facilitate lifting of heavy machines, eye bolts are used for lifting of heavy weights or heavy machinery. We are going to use these eye bolts. And this is an electric motor or maybe the generator, whatever it is. Here is also there an eye bolt which is used to lift the electrical motor. And next is this is the electric welding transformer. In this also there is an eye bolt which is used to lift the transformer. And here also you can see mud box wall. It is the wall. Here also we are having an eye bolt, collar type eye bolt. And here is the trolley. And here also this also having an eye bolt without collar. Eye bolt without collar. So friends, these are some of the applications. So far we have completed what is the eye bolt, what are the proportions of eye bolt, standard proportions of eye bolt, and how to design an eye bolt, and what are the applications of an eye bolt. So far we have completed. Now let us move on to the boiler stay. Screw boiler stay. Let me see, used for supporting one end plate of a boiler, as because the boilers are manufactured by using plates. So with this, in order to support the end plate of a boiler from the other end plate, we are going to use boiler stays. So fireboxes of locomotives, marine boilers are supported by screw stays, right? Fireboxes of locomotives and marine boilers are supported by screw stays. And what are mainly concerned with the direct stays? We are mainly concerned with only direct stays. Here you can see applications of boiler stay. This will be the boiler stay. This will be the boiler stay. And this is the plate, one plate, and this is another plate. And with this plate, we are going to connect by using boiler stay. So this is the boiler stay, firebox. This is the firebox or combustion chamber sheet. See here, this is the end plate. So this will be the boiler stay. So this is the boiler stay. This is the boiler stay. So types of boiler stays. Types of boiler stays. Direct stays, diagonal or gusset stays, guider stays. So these are the three types. Direct stays, number one. diagonal or gusset stays, girder stays. But in our syllabus, we are only concerned with the direct stays. We are in our syllabus, we are only concerned with the direct stays. So let us see design of stay. So this is the plate supporting, this is the supporting plate, and which is going to support the boiler plate. And here are the boiler stay points. This is the boiler stay points, and this is a distance from one to another. So in order to get this area, simply the supporting plate area as simply x into x. X will be the distance from one state to another state, right? So here we are going to take this end plate area into account. So right, friends, let us see the proportions of stay. Design procedure, sorry. P is equal to pressure of steam in boiler. X is the pitch of the stays, as we have seen in the figure itself. A will be the area of plate supported by each stay. So as we have seen in the figure, previous figure, x into x will be the area of plate supported by each stay. So this is the plate, and here from here to here is the x, and here to here is the x, and this is the boiler stay. This is going to support to entire plate. Similarly, this will support this much of area, and this will support this much of area. So each stay will support x into x area, right? So this is the area of plate supported by each stay. DC is equal to core diameter of the stays. DC is equal to core diameter of the stays, and sigma T is the permissible tensile stress for the material of stays. Sigma T is the permissible tensile stress for the material of stays. So how to design a stay? Now, from the inside, the boiler will apply pressure on the stay and supporting plate. So area of the plate supported by the each stay will be the x square, and p, small p, will be the pressure acting on the each plate. So capital P will be the force acting on the plate. So let us see, P is equal to force acting on the stay, P is equal to pressure into area. So knowing the force P, we may determine the core diameter of the stays by using the following relation. See, this will be the relation. Say P will be the pressure into area, and we also equal to, this is the diameter area of the stay at the core diameter, and sigma T will be the permissible tensile stress acting of the plate, and N will be the number of stays. So here DC is equal to under root of 4 capital P by sigma T pi into N. So the nominal diameter of the stay may be found by D is equal to DC by 0.84. So this is all about the design of stay. So in this design, in case of boiler stay, we have discussed about simply what is boiler stay and what is the need of boiler stay, and what are the types of boiler stay, just like direct stays, gusset stays, and then guided stays. So next is design of stay. So in this design, we got one formula. With this formula, we are going to get core diameter, and with this formula, we are going to get core diameter. From the core diameter, we will have nominal diameter. So this is all about the boiler stay. This is all about the boiler stay. See, let us see some of the problems. Let us see some of the problems. So design and draw an eye bolt using parameters. Lifting load is equal to 80 kilonewtons. Ultimate strength of steel is equal to 540 Newton per millimeter square. This is the ultimate strength of the steel. From this, we have to calculate by using factor of safety. By using factor of safety, you have to calculate permissible value or allowable value, right? So factor of safety is equal to 6. So now let us see the solution. Here, first of all, design and draw. So data is load to be lifted is equal to 80 kilonewtons, which is nothing but the 80,000 newtons. And ultimate strength of steel is equal to 540 Newton per millimeter square. In factor of safety is also given to you. So now factor of safety is equal to ultimate strength or ultimate stress by permissible stress. Permissible stress. So with the factor of safety and also ultimate strength, we are going to get permissible tensile stress. Permissible tensile stress. After getting permissible tensile stress, as we have discussed in the topic design of an eye bolt, P is equal to tensile load is equal to or load to be lifted is equal to pi by 4 dc square into sigma T. So that you have to apply yourself. So let us see tensile stress. Tensile stress Ft is equal to ultimate stress by factor of safety, and the tensile stress will be the just 90 Newton per millimeter square. Right? This is the tensile stress Ft. So load on the bolt or load to be lifted P is equal to pi by 4 dc square into Ft tensile stress, permissible tensile stress. After joining core DC is equal to core diameter of the bolt. So if you apply, substitute all the values as we are having the P value and Ft value, then you can substitute, you are going to get simply core diameter, that is 33.64. 33.64 will be the core diameter. So with this core diameter, we are also going to calculate nominal diameter. Simply nominal. So nominal diameter of bolt is equal to core diameter of the bolt by 0.84. This also you can use, this relation also you can use it to calculate nominal diameter, or otherwise you can go to the tabular form. That means correspondingly to the core diameter, we have to select properly the nominal diameter. So core diameter is equal to 33.64, and then corresponding bolt size will be M39 from the Simply you can take from the tabular form, tables, standard tables, right? So then the proportions of an eye bolt. So each and every proportion you should calculate. Each and every proportions you have to calculate. So diametric thread portion D is equal to 39. Anyway, from the design calculations, we got it. And then length of the shank is equal to 1.5 D, which is also equal to 58.55 millimeters. Next is diameter of the collar is equal to 2D, which is also equal to 78 mm. Right? These are the proportions we are calculating. And thickness of the collar 0.32D, that is 12.48. And the diameter of the ring rod 0.8D, that is 31.2. Inner diameter of the ring is equal to 2D, that is 78 millimeters. And outer diameter of the ring 3.6D, that is 140.4 millimeters. Now this is the proportionate sketch of an eye bolt for the previous problem. As per proportions, the sketch of an eye bolt to be drawn just like that. Means this is the length of the threaded portion, this is the thickness of the collar and diameter of the collar, neck diameter of the neck diameter, inner diameter of the ring, outer diameter of the ring, and this is, you can see, ring rod diameter, and this is from base of the collar to the center of the ring. So all these proportions with just like this you have to draw, right? So diameter of the neck 1.36D, 53.04. Distance between the center of the ring and bottom of the collar 2.64D, that is 102.96. So that is the problem 1. Now that is previous problem is on eye bolt. Now the problem is on boiler stay. The longitudinal bar stays of a short boiler are pitched at 350 mm horizontally and vertically. That means this is the X value. This is the value of X. So with this, that means vertically 350 mm, horizontally 350 mm, X and X. And that will give you the area of the plate supported by the boiler stay. Then the steam pressure is 0.85 Newton per millimeter square. This is the pressure value. After getting the plate area and we are having the pressure, we are going to get the load acting on the boiler stay. So then find the size of mild steel bolts having a tensile stress as 56 megapascals. Right? Let us see the solution. So steam pressure is equal to 0.85 Newton per millimeter square, and area A is equal to x square or x into x, 350 into 350, that is 1,22,500 millimeter square area is supported by each boiler steel. Right? So sigma T is also given to you 56 newtons per millimeter square, or in terms of megapascals. 1 megapascal is equal to 1 Newton per mm square. Thereby directly we can convert this from megapascals to directly you can write in Newton per millimeter square. Right? Let us have the force acting on each step P is equal to pressure, steam pressure into area supported by the boiler stay. Right? P into A. With this you can get your load. That means force acting on each stay. Force acting on each stay, that is 1,04,125 newtons. And this force must be, this force acting on each stay must be resisted by the stay. That means now resistance offered by the each stay. DC will be the core diameter of the bolt. So we know the resisting force on the bolt P, and P is equal to pi by 4 DC square into sigma T. This will be the resistance by each boiler stay or the bolt, right? So DC is equal to under root of 4P by sigma T pi. After substitution, we are having the pi, we are having the sigma T 56. So if you substitute these two values, you will get a core diameter as 48.66. 48.66. So correspondingly, the corresponding nominal diameter will be DC by core diameter by 0.84. So you will get 57.57 millimeters, and that should be taken as next nearest value, that may be 58 or 56 is wrong. Actually, it should be the 58, not less than 57. Thereby, 58 should be taken. M58 must be adopted, right? So this is the boiler stay problem. Now let us have the summary of this lesson. Summary of this lesson once again. We have discussed about types of eye bolts, design of lifting an eye bolt, solution of some of the problems of lifting eye bolt. So also we have discussed about applications of an eye bolt. And next, after completion of the eye bolt, we have also discussed about the design of screw boiler stay, applications of screwed boiler stay. So this is all about the summary. That means whatever we have discussed so far, whatever we have completed so far, this is the summary, right? We have discussed about an eye bolt. What is the eye bolt? What is the use of eye bolt? Right? Next is the proportions of an eye bolt and types of eye bolts, applications of eye bolt, design of eye bolt. And next is boiler stay. What is boiler stay? What is the use of boiler stay? What are the types of boiler stays? Design of boiler stay. After the completion of their theory of an eye bolt and boiler stay, we have done two more problems. One is on eye bolt and one is on boiler stay. Right? So now let us have a simple quiz on this nominal diameter of a lifting eye bolt. D is equal to AB. Option A is DC by 0.5. B option is DC by 1.5, and C option is DC by 0.84, and D option is DC by 1.84. So which is the right answer among these four? So simply we can say this will be the right answer, DC. C is the right answer, DC by 0.84. Let us see. Okay, right? C is the right answer. D is equal to DC by 0.84. So outer diameter of the ring of an eye bolt, outer diameter of the ring of an eye bolt, 2D, 1.36D and 2.36D and 3.60. Which is the right answer? Generally 2D is not right answer because it is the inner diameter of the ring of an eye bolt. and this is the neck diameter, and this is not correct, which this is not there in the proportions, and this will be the right answer. D will be the right answer as per my concern, right? So D is the right answer, right? So friends, so once again, let us see one by one, a simple at glance review the total in a simple manner. So eye bolt is mainly used for lifting of loads, number one, and consists of cross section, which is forged into a screwed shank integral to it, and then a screwed inside a threaded hole on the top of the machine. So this will be the screw which is going to be fitted in the machine itself to lift the loads. And types are the eye bolt with the egg link, eye bolt with collar, simple eye bolt with star point, and these are the proportions, various proportions of an eye bolt, and empirical relations. That means empirical proportions of an eye bolt. These are all the empirical proportions that we are having with us. So next is the design. That means load to be lifted or tensile load acting on the bolt should be resisted by the bolt itself. So P is equal to sigma T pi by 4 DC square. This will be the formula for the design of an eye bolt. And applications, here you can see for lifting of loads. So here is the electric motor and welding transformer, mud box valve, and trolley. All these are the applications. In all these cases, we are going to use eye bolts for lifting of loads. And boiler stays used for supporting one end plate of a boiler from other end plates. So fireboxes of locomotives and marine boilers are supported by screw stays, and these are the applications. And this is the simple boiler stay, which is threaded at two ends. In types by direct stays, diagonal or gusset stays, guided stays. And this is the area. This will be the area supported by the boiler stay. So now x square will be the area of plate supported by each stay. Now this will be the core diameter, sigma T is the permissible tensile stress for the material of stay, and the design is simple. Force acting on the stay should be resisted by the stay. So this is the formula that you are going to have, and n will be the number of boiler stays. So, and also we completed two more problems, right? And also we completed boiler stay problem, and also we completed summary, and also we completed a small quiz. That is, one is the based on the nominal diameter of a lifting eye bolt, and another is on outer diameter of the ring is 3.6 D, which is nothing but the answer is D. Next one is boiler stays are used for erection of boilers, supporting end plates of boiler, heating of boilers, supporting end plates of a boiler. This is the right answer. Boiler stays are used for supporting end plates of a boiler. Right? Boiler stays are screwed into a boiler plates, screwed into the boiler, not screwed into the plates and boiler. Which is the right answer? Screwed into the boiler plates. So right. So with this we concluded our lesson today. So thank you friends. Bye.